Hello and welcome to the lesson video notes for Chapter 7, Lesson 1, Ratio and Proportion. Once again, make sure you have already completed the vocab in the note packet and your vocab notebook before watching the video. Today's objectives will be to write and simplify ratios and use proportions to solve problems. We will be talking about what a ratio is, what a proportion is, the extremes and means of proportions, and what cross products are. These are terms you may recognize from Algebra 1. A lot of this material might come from previous classes, but we will be applying it to certain geometric figures later in the chapter, so this is a good review. Remember, a ratio compares two numbers by division. The ratio of two numbers, a and b, can be written as a to b, or a colon b, and we would still read that a to b, or a over b, which is a fraction, as long as b does not equal 0. For example, the ratios of 1 to 2, 1 to 2 with a colon, and 1 over 2 all represent the same comparison. Remember, in a ratio, the denominator of the fraction cannot be 0 because division by 0 is undefined. It's impossible. So let's start off by applying ratios to something we've already talked about. We were to write the slope of line L, having points A and B, as a ratio. Well, we've done that many times. Remember, slope is rise over run, the ratio of rise to run. We can use this formula to find that. So we are going to talk about the rise, y2 minus y1, and fill in what we know. y2 is negative 2. y1 is 3. Over the run, x2 minus x1. x2 is 2 minus x1, which is negative 1. Minus a negative 1, I'm going to rewrite as plus positive 1. So negative 2 minus 3 is negative 5, and 2 plus 1 is 3. So we can see that the slope of line L is the ratio negative 5/3. Now, a ratio can involve more than two numbers. For the rectangle, given here, the ratio of the side lengths may be written as 3 to 7 to 3 to 7. Even though we've only talked about two number ratios before, we can write the ratio of the side lengths of any polygon, which could have any number of sides. The proportionality still works. In this example, the ratio of the side lengths of a triangle is 4 to 7 to 5, and its perimeter is 96 centimeters. We are to find the length of the shortest side of that triangle. Well, we could say that the triangle had lengths 4 centimeters, 7 centimeters, and 5 centimeters, but if I added those, I don't get 96. But this ratio tells us that the side lengths could also be 8, 14, and 10. If I were to multiply all these by 2, I would still be in that ratio. But those don't add up to 96 either. They could be 12, 21, and 15. Those don't add up to 96. And we could keep going along this pattern, multiplying 4, 7, and 5 by the same number until we found a set that added up to 96. That's the guess and check method. Rather than use that, we can set up an equation by letting the side lengths be called 4x, 7x, and 5x. The same multiple of 4, 7, and 5. X is going to be the same number in all three cases. Then if I add these expressions to get the total 96, I only have to solve this equation using my algebra skills and find out what x is to find out what 4 times that value is as the shortest side. So let's solve this equation. We're going to start by combining like terms. 4x plus 7x plus 5x gives us 16x. 16x equals 96. And now we only need to divide by 16 on both sides to find out what x is. In doing so, we get that x is 6. So these sides will increase by a factor of 6. Alright, your next vocabulary term is a proportion, and you might remember these from Algebra 2. A proportion is an equation stating that two ratios are equal. In the proportion a over b equals c over d, two equal ratios, the values a and d are called the extremes. The values b and c are called the means. This is a little bit easier to understand why we use these words when you write it out in this form. Remember, proportions involve two equal ratios. So I could write the ratios using the colon notation here. We would say A to B equals C to D. The extremes are in the first and last position, the extreme ends of this equation. The means are in the two middle positions. So we have the cross product property from Algebra 1, which states that if we have a proportion, A over B equals C over D, and the B and D values are not equal to 0, then the cross products are equal. Or in other words, the product of the extremes is equal to the product of the means. So what that tells us is that if I take A times D, that must be equal to B times C. You may have also heard math teachers say that in order to solve a proportion, you cross multiply. We find the cross products. So in example 3a, we are given the ratio 7 over x equal to the ratio 56 over 72. Rather than guess and check to find the value of x, we simply use the cross product property. If I were to multiply the extremes, 7 times 72, that must be equal to the product of the means, x times 56. Well, now we just simplify this side and solve the proportion for x. 7 times 76 is 504. That must equal 56x. Now we need to divide both sides by 56. And in doing so, we get that x equals 9. Since there are no units of measure, we're just talking about the value of a variable, x equals 9 is your final answer. In example 3b, however, you notice this problem is a little bit different. The extremes are the binomial z minus 4. When we multiply z minus 4 times z minus 4, we should recall that while I can write it z minus 4 times itself, I could also call that z minus 4 squared. Z minus 4 times z minus 4 is z minus 4 squared. And then I need to take the product of the means, 5 times 20. 5 times 20 is 100. So z minus 4 squared equals 100. To go from here, there are two methods in which we could do this. We could take z minus 4 times itself and FOIL that. If you write it out as z minus 4 times itself, we could use FOIL. But since 100 is a perfect square, I'm not going to use that method. We are going to take z minus 4 squared equals 100 and take the square root of both sides. But since we're just talking about the value of a variable and not real-world measurements, we must consider both the positive square root and the negative square root of both sides. Don't forget that. You'll remember we talked about that towards the end of chapter 6. So if we take the positive and negative square root of both sides, we get z minus 4 all alone on the left side. On the right side, we would consider positive and negative square root of 100. Well, the square root of 100 is 10. So I really must consider positive and negative 10. This tells me we can split this into two equations. Either z minus 4 equals positive 10, or z minus 4 equals negative 10. In this equation, if you add 4 to both sides, z would be 14. But in this equation, if we add 4 to both sides, z would be negative 6. These are the two answers we get for z in this proportion. You would always want to double check and make sure that neither of these answers would give you a denominator of 0. Negative 6 minus 4 is not 0, and 14 minus 4 is also not 0. This table shows you equivalent forms of cross products. If I were to have a over b equals c over d, then the cross products will give me this. But this same cross product can be obtained from either of these two proportions. This is an example of that. 1 times 6 equals 3 times 2. But I could also have 1 times 6 as the means and 3 times 2 as the extremes. Or I could switch the positions of the 2 and the 3, and it would still give me this proportion. So it's important to recognize which ratio we are comparing. So in example 4, we're given a cross product, and we want to find a specific ratio d to c in simplest form. That means we will have to reduce our fraction to its simplest possible form. So we're starting off with 18c equals 24d. I'm going to rewrite it exactly as it's written here. I want to find the ratio of d to c. Remember, if I write the ratio as d to c this way, I can write that as the fraction d over c. So what I want to do is take this equation and change it so that I have d over c on one side of that equation. Well, d is on the right, c is on the left. So I need to get them on the same side of the equation. In order to do that, I would either have to divide both sides by d or divide both sides by c. You have to figure out which one would leave d on the top of the fraction and c on the bottom. You'll notice d divided by c on both sides would give us that result that we want. So the first step here is to divide both sides by c. The c's cancel on the left, so we have 18 equals 24d all over c. Well, I have d over c now, but this 24 has to be moved to the other side. This is 24 times d. So in order to move it to the other side, I must divide both sides by 24. On the right-hand side, 24's cancel, and I do have the result, d over c, that I wanted. But on the left, I need to reduce the fraction, 18 over 24. You'll notice the greatest common factor of both 18 and 24 is 6. So if I divided both sides by 6, I get 3 over 4. So the ratio of d to c equals 3 to 4. In our final example, we have a situation where Marta is making a scale drawing of her bedroom. Her rectangular room, so the shape is a rectangle, is 12.5 feet wide and 15 feet long. On the scale drawing, the picture she draws will have a width of 5 inches. What length would need to go with that? Well, we can set up a proportion that compares the width to the length of the scale drawing, and that would equal the width to the length of the full-size room, where x is going to be the length of the room in the scale drawing. So we simply need to fill in what we know. The ratio of length or width to the length of the scale drawing would be 5 to x. The ratio of width to length of the full-size room would be 12.5 to 15. Why don't you take a few moments, pause the video if you need some extra time, and solve this proportion. Remember, cross products property tells us 5 times 15 equals 12.5 times x. Once you have a value for x, you can click play and check your result. All right. The answer you should get is that x equals 6 inches. Remember, the scale drawing is in unit of measure inches, so that is how we come up with that unit of measure. All right, that completes our lesson on ratio and proportion. Hopefully this has been a good review, and you'll do a little bit better when we work on the assignment in class. If you have any questions, make sure you ask when class resumes.